Let's start with, let's take the notion of the oscillator and put it aside. Let's take the notion of the filter and put it aside. Let's even take the notion of the envelope and put it aside. All you're left with in a synthesizer is voltage control. And here's how. I'm going to press a note. I'm going to voltage control the pitch of this note. Now, I want you to imagine my left hand as voltage control, because this is all voltage control is. My hand is exerting voltage control over the pitch of this oscillator right now. And when voltage control is happening, that's all that's happening. There is a hand that is turning a knob somewhere. Now, granted, that's metaphor. There isn't actually a hand inside of your synthesizer turning a knob somewhere. But really, voltage is the voltage output from what we're looking at here is changing the pitch of the oscillator. And I am telling this voltage source what voltage to output, which causes the change in the pitch of the oscillator. So when you have, for example, an LFO with a sine wave, which is connected to the pitch of your oscillator, and it's doing this, it's literally doing that. That's all that's happening. This is voltage going down and up and down and up. And that voltage is causing the oscillator's pitch to go down and up and down and up because it can be voltage controlled. In this instance, we can see what a slight variation in voltage in a sine wave shape will do to the pitch of the oscillator. Look at the oscillator frequency knob. See that slight turning? That's what this modulation is doing to the pitch of the oscillator. If the variance in voltage were large, look at the degree to which the oscillator frequency, the pitch of the oscillator, would vary. Okay, and that's the same thing if you put like an envelope control on your oscillator and it does this. The voltage control, you have set it so that that pattern of voltage through the envelope causes the pitch to do that exact thing. And it's the same as if we plug this into the filter. Filter modulation. That's like LFO applied to the filter. As you can see, the slight modulation, a slight variance in voltage in a sine wave pattern is affecting the filter cutoff to a slight degree. With a greater variation in voltage, look at the filter cutoff knob. You can see exactly how much the voltage is changing the filter cutoff point, resulting in what it would sound like if you took the knob and turned it to that degree. Here's like a filter envelope. Here, let's make this a little more. When you have an envelope applied to your filter and it's doing that wow thing that I was just doing, the knobs in the envelope are set to deliver this voltage, the voltage that goes from this point, more voltage, and then less voltage again. More voltage and less. That is exactly what's happening. It's like a little hand turning the filter cutoff knob, just like my hand is turning this knob right here. I can emulate sample and hold just by changing this randomly to random different points. That is all that sample and hold is doing.